Okay, we will solve the next exercise. The exercise is telling us in example 1.3, instead of Einstein equation, consider the equation L equal to mc, where the mass m is in kilograms and the velocity of light c is in meters per second. A. What are the international system units for L? If the value B. If the value of L in international system units is 12, what is its value in US customary base units? Well, the first thing that we have to recognize here is that this information, I don't care about this information. Example 1.3. Because what we have to do is to take into account the principal equation and then use some maybe some change of units along the exercise. So let's begin with that. The principal equation is L equal to mc. The exercise is telling me that n is in kilograms and c is in meters per second. So the first question is, what are the international system units of L? Well, this is pretty easy actually, because if L is equal to mc, then the units of L will be kilograms multiplied by m, which is meters, divided by seconds. Those are the units. I cannot play with this. I cannot do anything else with these kinds of units. So this is the answer for the first part of the exercise. Then the second part of the exercise is the value of L is in if the value of L in international system units is 12, what is its value in US customary units, US customary base units? So I gotta transform 12 kilograms times meters per second into US customary base units. And for you to, this is like the most important part of the exercise, because the next part of the exercise is just playing with divisions and multiplications. But when we talk about US customary base units and we are talking about a mass, then we have to talk about a slug, which is the unit that measures mass in the US customary base units. Then I'm going to use the principal unit for the US customary units to measure length, which is the feet. And the seconds are the seconds. That is actually never changed. Then, for me to do this, I gotta multiply this by a division, in which I'll have the kilograms on the denominator part of the division and the equivalence into the units that I want to get on the numerator part of the division, slugs. And then I'm going to do the same thing with the meters and the feet. So as I just said, here I have the units that I currently have, and here I have the units that I'm gonna get. The same thing here. Why am I putting the kilograms on the below part of the division? Well, because I have the kilograms here on the upper side of the division. Remember that this is the same as having kilograms multiplied by meters divided by seconds. Alright? And the same explanation for this part. Because I have the meters here, I gotta put them on the denominator part of the division. Then I gotta write down here some equivalences. So the first one is the slugs into kilograms. I could write the equivalence between 1 kilogram in 2 slugs, or the one that I know, which is 1 slug is equal to 14.59 kilograms. And then I'm going to write the equivalence in here between meters and feet, which is 1 meter is equal to 3.281 feet. How do I know this? By memorizing it. There is not other way. Now I gotta write down that on the calculator, which is 12 multiplied by, or I can just write this, 14.59 and multiplied by 3.281. Why do I do this kind of notation on the calculator? Because this is principally 12 times 1 divided by 14.59 times 3 divided by 3.281 divided by 1. So this is actually 3.281, and this is actually not doing anything. So it's the same thing as I divide the result of the multiplication of these two numbers. Alright, now the result is 2.69. I'm going to use 4 significant digits after the point. 6985, and the units are slugs multiplied by feet per second. Why is that? Because I eliminate here the kilograms, here the meters, and here I have slugs times feet divided by seconds. And this is the final answer for the second part of the exercise. And that's how, guys, you can solve this exercise.